So we are doing the quiz right here. And the first set of directions say to simplify. And if you remember, when we're talking about simplify, that means we're putting everything together. We are adding, we are subtracting, we are multiplying, and we are dividing. So when I look at this up here, the first question I ask myself, can anything inside the parentheses be combined? Okay? So anything inside the parentheses, if they can be combined, then we would go ahead and do that. There is nothing inside of either one of these. The second thing that we ask ourselves, is there anything that needs to be distributed? And we have a plus sign right here, so that does not need to be distributed. So I can rewrite this as 6x squared minus 6x minus 1 plus negative 9x squared minus 9x plus 8. Now, many of my students don't rewrite it, and that's okay? But I'm rewriting it to show you that what I've done is I've dropped the parentheses. Now I'm looking at like terms. Here I have 6x squared. Here I have negative 9x squared. Okay? Together, those are negative 3x squared. I do not write x to the fourth. It's x squared because I am adding. I am adding like terms. Okay? You don't start adding exponents until you're multiplying monomials. Okay? Now I've got negative 6x, negative 9x. That's negative 15x. Then I have negative 1 and positive 8. And that gives me positive 7. So I have combined like terms and I've simplified here. Okay? Can I go to the next one? Okay, this one is a little bit more challenging for a couple of different reasons. The first thing that I want to ask myself, is there anything inside the parentheses that needs to be combined? And the answer to that is no. There's nothing inside parentheses that need to be combined. However, for this one, there is a negative that needs to be distributed. Now, if you choose not to rewrite this one, that's okay. But sometimes because we're distributing a negative, students make mistakes when they don't rewrite it. So I would encourage you to rewrite this one. So I have 4x squared plus 5x minus x to the third plus 1. Then I am distributing this negative to everything. So I have negative 9x squared. A negative and a negative make it positive 8x. Negative and a negative make it positive x to the third. Then I've got minus 6. So it is a good idea to write this one down because you've got to distribute that minus sign to everything in that second polynomial. Now, the second reason that students miss this one is because this is all out of order. Typically, when you see a polynomial, your highest exponent comes first. What's the highest exponent in here?
Well, x squared, because x to the third power will cancel itself.
You're correct. The x to the third power will cancel out. But as it's written right now, x to the third is our highest exponent. Okay? So traditionally, you're going to want to deal with that first. So you've got negative x to the third and positive x to the third, and they do cancel out. And it cancels out nicely, and it makes things a little bit easier on us. Okay? But that is awkward because it's not in descending order. Okay, I've got 4x squared, and I've got negative 9x squared. That gives me minus 5x squared. Positive 5x, positive 8x, gives me 13x. Positive 1 and negative 6 gives me negative 5. And I can't go any further on this because x squared and x are unlike terms. x squared and x are unlike terms. Okay, numbers 1 and 2, we were adding and we were subtracting. Number 3 is when we start using exponent rules. Okay, number 3 is when we start using our exponent rules. When we are adding and subtracting monomials and polynomials, like what we were doing here, our exponent rules don't apply because our exponent rules only apply when we're multiplying and dividing. So be careful there. Here, we are multiplying, so we've got to deal with our exponent rules. What I do first is I look at my numbers. I've got -4 times +8. What is -4 times, I've got -5. Thank you. -5 times +8.
-40.
It's -40. See, my brain was just a little bit ahead. -5 times +8 is -40. Then I'm going to deal with the x squared times the x to the 4th. When I am multiplying the same base together, what do I do with the exponents?
You add them.
I add them. So I have x to the 6th. Woo, you guys might need to send me home. X squared times x to the 4th is x to the 2 plus 4, which is x to the 6th. Okay, now our next one, we have y squared times y. Now this y has a 1 right there. Don't forget that if you do not have an exponent written, there's an exponent of 1. So this is y squared times y to the 1st. We still add those exponents, and what do I get? Y to the y cubed, or y to the 3rd. What happens with this particular problem right here is students try to FOIL this. They try to FOIL number 3. You don't FOIL number 3. We FOIL number 4 because we've got 2 binomials. We have addition or subtraction. We don't have any addition or any subtraction there. So we're not FOILing, we're just multiplying. Okay? Here we are FOILing. I have 2x times 5x. That is 10x squared. 2x times -4
-8x
is -8x. -9 times +5x.
-45x.
Good. -9 times -4.
+36.
Okay. Always check right here. Okay? A lot. Not every single time, but very often you're going to have a common term in there that you can add together. Okay? And we do for this one. So I have 10x squared minus 53x plus 36. Okay? This is a situation where we FOIL. This is when we FOIL. Okay, our next one, we FOIL again. Okay, we've got a binomial times a binomial. You might have figured out that this is a difference of perfect squares. Okay, I've got 7x plus 5 and 7x minus 5. That's the difference of perfect squares, and that would matter if we were factoring. We're not factoring, we're multiplying here. So I am still going to FOIL, and if you don't identify that as a difference of perfect squares, it's not a big deal. You'll realize it as soon as your middle terms cancel. Okay? So when you are multiplying, you do not have to be able to identify it as difference of perfect squares. It's not necessary. So here I'm going to do 7x times 7x. That's 49x squared. I have 7x times -5. That's minus 35x. Then I have 5 times 7x. That might be when you realize you're dealing with difference of perfect squares because your middle terms cancel out. Then you've got 5 times -5, and you would have minus 25. Okay? Yes?
So if if we just have those two, we just do square root, right?
If you are factoring, yes. If you're factoring, you just do the square root. But here we're being asked to multiply, so we would square them.
I know, I was just asking since that was a question like
Yes.
that.
Yes. Okay. Now again, the multiplying, the dividing, the foiling is typically not where we struggle. Sometimes we might make a mistake or two with addition, but typically where we struggle is the factoring. So starting with number 6, we have to factor. Okay, now I just want to remind you some of the techniques that we use when we are factoring. Okay, the first thing that we always look at, always, we look to see if there is a GCF that I can take out of everything. Okay, that is our first step every single time, no matter what. Is there a GCF that I can take out of everything? Okay, the second thing I ask myself, can I factor by grouping? In order to factor by grouping, I have to have 4 terms. Okay, do I have 4 terms? This has to be factored by grouping. So we are going to factor this one by grouping. Okay? The next thing that I would ask myself, is it a special product? Okay, the special product that matters the most is difference of perfect squares. You've got to be able to identify difference of perfect squares. If you have a perfect square trinomial and you do the product and sum, you're going to be okay. But if you don't identify a difference of perfect squares as difference of perfect squares, then you're going to miss it. Okay, so that's the special product that you want to be aware of. Then your fourth type is to factor your trinomial. Okay, and you have x squared plus bx plus c. Okay, that's when c is your product and b is your sum. Then you have ax squared plus bx plus c, and that's when a times c is your product and b is your sum. Okay, so to factor by grouping, what we do is we are going to look at my first 2. Okay, I have 2a to the third plus 10a squared. A 2 comes out of both of those because those numbers are even. And an a squared comes out. Okay? 2a squared times a gives me 2a to the third. 2a squared times 5 gives me 10a squared. Okay? The next thing that I'm going to do is I'm going to look at my last 2 terms. Okay, I'm going to look at my last 2 terms. I can take a 7 out of both of those, and I'm left with a plus 5. Now, this right here, these 2 things have to be the same. If they are not the same, then you have made a mistake somewhere. Okay, they have to be the same. Then, a plus 5 is one of my binomials. You're not done. You're not finished. Okay, and then you have to put 2a squared plus 7. That is your other binomial. Okay? This right here is your other binomial. 2a squared plus 7. That's your other binomial. Okay? Factoring by grouping comes up again when we are factoring like this right here. Okay? So you have got to be able to factor by grouping to be able to solve these. Okay? Did you figure it out?
Yeah.
Good.
there.
That's okay. We'll fix it by Friday.
Okay.
That's what you want to do. Okay. Can I go to the next screen? Has everybody got this one? Okay. Now I've got x squared minus 6x minus 27. There's no GCF. We cannot factor by grouping. Why can we not factor by grouping? Because I don't have 4 terms. Okay, it's not a special product. It's not difference of perfect squares. So I have to use the trinomial methods. Now, students get confused trying to decide what to do when there's a number in front of the x squared and when there's not a number in front of the x squared. This one does not have a number in front of the x squared. So what we have is x squared plus bx plus c. C is our product, and B is our sum. Okay? So in this situation right here, negative 27 is my product. So I'm looking for 2 numbers that I multiply together to get negative 27. My sum is negative 6. So what I do is I start looking at my product. Negative 27. Okay? There's not a lot. I've got 3 and I've got 9. I've got 1 and 27, and that's it. Now, I have a negative product, and a negative sum. Because my product's negative, one number is negative and one number is positive. The larger absolute value, is it positive or negative? Negative, and that is because of this right here. When I have a negative sum and a negative product, my larger absolute value is negative. So for this, that makes my 9 the negative one. Okay? So now all I do, because this is a 1, I am allowed to do this only because this is a 1. Okay? I can do x plus 3 and x minus 9. Okay? And I can do that because it is this form. Our very, very next one is not that form. So we have to do it differently. Can I move off this? Good? Okay. Now, this one is different. This is ax squared plus bx plus c. I have something in front of my y squared. Okay? So in order to get my product, I have to multiply my a and my c together. My sum is still b. Then ultimately, after I deal with all of that, I am going to be factoring by grouping. Okay? Because when I have an a in front of my squared value, I am going to split my b term. Okay? These are the types of problems that give students headaches. Students are like, oh, I know how to factor. I just don't know how to factor when you put a number in front of the x squared. Okay? That happens a lot. I hear that a lot. I hear that in my 144 class. Alicia, I totally have factoring, except when there's a number in front of that squared value. And I'm like, then we need to work on factoring. This is the last thing that'll click, but when it's clicks, you'll get it. Okay? So in order to do this, the first thing that I do the first thing that I'm going to do is I'm going to take my 10 and I'm going to multiply it times my 12. Okay? I'm going to take my 10 and I'm going to multiply it times my 12. So my product here is going to be 120. Okay? My sum is going to be that b value, that negative 23. Now, when I have a positive product, my numbers have to be both positive or they have to be both negative. Okay? Positive product, They have to be both positive or they have to be both negative. Because my sum is negative, what does that tell you about my numbers? They're both negative. Excellent. So I am looking for two negative numbers. So both numbers are negative. Okay? That's what we're doing right here. We're looking for two numbers that are negative. So I'm going to start writing out factors of 120. So the easiest is 12 times 10, and they're both negative. Okay? It ends in a 0. So not only does 10 go into it, what else goes into it? 5 goes into it. So negative 5 times what? Gives me 120. I'm assuming it's 24. It is going to be 24. Okay? Now, will 30 go into this? Yes. 3 times 4 is 12. So that means 30 will go into it. Okay? And so then we're going to have negative 30 times negative 4. I can flip that and do negative 40 times negative 3. I'm still not there yet. This is something that students miss. It's something to keep in the back of your head. If 30 is a factor, so is 15. Okay? So 15 is a factor here. Anytime that 30 is a factor, and 30 is a factor for number 8 and 30 is a factor for number 9. Anytime that 30 is a factor, 15 is also going to be a factor. Okay? So here, I would have negative 15 and times negative 8. And those are my numbers right there. Those are my numbers. Right there. Okay? Okay, so now what I'm going to do is I am going to split my B term. I'm going to split my B term. So I have 10y squared minus 15y minus 8y plus 12. Okay? Now I'm factoring, so I have split my B term. Now I've got to factor by grouping. And we just talked about how to factor by grouping. What goes into my first two terms? What comes out of 10 and negative 15? 5. What variable comes out of that? Good. So then I'm left with 2y minus 3. Okay, what comes out of my next two terms? Not just 4, but negative 4. Okay, and then I've got 2y minus 3. So my final answer here is 5y minus 4 times 2y minus 3. Okay? So the problem here, and where students get confused, is trying to list all the different products. So remember, this is going to come in handy. If 30 is a factor, so is 15. Okay? Is it okay for me to go to the next one? The next one is very similar.
How many problems are there?
12. Okay? You're welcome to leave if you feel like you need to. You're fine. You don't have to stay. I know you were just looking for number 4 or 5. Okay. I've got a variable in front of that squared value. Okay? So that means I've got to do the AC method. Okay? So I've got to say 20 times negative 9. 20 times negative 9. So my product here is what? Negative 180. My sum is 3. I have a negative product a positive sum. So I am going to have one positive number, one positive number, and one negative number. Which one's going to be positive? Okay, so I have a positive sum. So the greater absolute value number is going to be positive or negative? It's going to be positive. Good. So my greater absolute, I don't think I spelled that right. How about this? Is that right? Absolute? Greater absolute value is positive. And that is because our sum is positive. That's what that means when our sum is positive. Okay? Because our sum is positive. So we've got to find two numbers, multiplied together give me negative 180, added together give me 3. So I'm going to start. I've got negative 10 and positive 18. Okay, if 10 goes into it, what else goes into it? 20. Actually, 20 does too. So I would have 20 and 9, or negative 9. Okay, if 10 and 20 go into it, what else goes into it?
30.
Well, actually, 30 does too. What I'm getting at is that the number 9 goes into it. I mean, the number 5. So I'm going to have negative 5 times what? 36. Good. Okay, what did we say about 30?
If 30 is there, then there's 15.
Good. If 30 is there, 15.
It's 15 and 12.
It's 15 and 12. That's the two numbers, 15 and negative 12. Okay? So I'm splitting my 3. So I have 20z squared plus 15z minus 12z minus 9. Okay? At this point, we are factoring by grouping. 5z, so I'm left with 4z plus 3. Now, what have I told you? If we have a negative right here, what have I said?
And do a negative.
Good. I'm going to pull out a negative 3. Then I'm left with positive 4z plus 3. So my final answer here is 5z minus 3, 4z plus 3. Okay?
Oops.
And I would say 8 and 9 are probably the hardest on the quiz. I would say 8 and 9 are probably the hardest. Number 12 often sends people into a little bit of a frenzy, but once you see it, it's not too difficult. Okay, can I do number 10? What's number 10? It's perfect squares.
Square.
Okay? 25 is perfect. X squared is perfect.
So it would be square root.
So we are going to have to, we are eventually going to do the square root. 64 is perfect. Okay, so you've got a perfect square at the beginning, you've got a perfect square at the end, and what is the absolute must?
Square root.
Not yet. What has to be going on between the two? Got to be subtraction. If it's not subtraction, it doesn't work. It's got to be subtraction. Okay, so Mark, you said we're going to take the square root of 25x squared. What is that?
5x.
5 and the x. Good.
And
So,
then it's 8.
okay,
Each side,
you're correct.
which is negative.
Oh, hold on. You're right. Okay, then we're going to take the square root of 64. Square root of 64. The square root of 64 is 8. One of them has to be positive. One of them has to be negative. It has to be that way. They're not both positive. They're not both negative. One each, because when we FOIL, what happens to the middle terms? They cancel out, and that's what we want to happen. This is your special product, difference of perfect squares. Okay, number 5 was also difference of perfect squares, but it's not important for number 5 for you to be able to identify it, because you will figure it out in the middle of your FOILing when those two middle terms cancel. Here, when you're factoring, you've got to be able to identify it. And these are the three things that you've got to identify. A perfect square is your first term, a perfect square is your second term, and they've got to be subtracted. Okay? Now, in general, can I go off this screen?
Yes.
Okay. In general, students typically do pretty well on this one right here. We've got an equal sign. Okay, so we are solving. We are solving because we've got an equal sign. Okay? Because it's squared, we've got to go ahead and factor it. We have an A value of 1, so this one factors relatively straightforward. Okay? So I've got a product that's negative. So my product is negative 40. My sum
Is negative 6.
is negative 6. So I'm looking for one positive and one negative number. Since my sum is negative, the greater absolute value will be what? Good. The number with the greater absolute value will be negative. Anybody know what the numbers are? Good. X minus 10, X plus 4. Now, the reason that I can do that, the reason that I can go straight from x squared minus 6x minus 40 to x minus 10 times x plus 4 is because my A value is 1. That's the only reason I can do that. If I had a 2 or a 4 or even a negative in front of that x squared, I couldn't do it. Now,
It would be x equals 10 and x equals negative 4.
okay, so now what I'm going to do is I'm going to take each factor and I'm going to set each factor equal to 0. Okay, and then I solve. So I have x equals 10 and x equals negative 4. Okay? Now, number 12 gives everybody fits. Number 12 gives everybody fits. And I tell everybody that's doing it, you are making it harder than it is. That's what I say.
Yeah, because the x is not in there. You can just simply do the other one.
You can. Okay, so here it is. I have x, and I have 8 plus 4x equals 0. Now, one of your options, something that you could do, because it is already factored to x and 8 plus 4x, you could go ahead and set each thing equal to 0. You could say x equals 0 because this is a factor. And then you could set 8 plus 4x equal to 0 because that's a linear factor. So x would be 0. Then you would have 4x equals negative 8. So I took negative 8 from both sides. And then I divided by 4. You could do it this way.
I actually forgot to do the 0.
Okay.
I only did the negative.
Okay. Okay. So my answers to this are x equals 0 and x equals negative 2. The reason that I could go ahead and set these equal to 0 is because it's already factored. It's not factored how we would want it factored, but it is already factored, and so it would work. You just set it equal to 0, and you've got some math that you've got to do on the other side, and that's okay. What many students do is they go ahead and distribute this, okay? So they end up with 8x plus 4x squared, okay? And then they remember. Students are like, ooh, that 4x squared usually comes first. Completely fine. 4x squared plus 8x equals 0. Now I can factor out a GCF. Factor out the GCF. Okay, I have a 4 and an x that can come out of both of those. So then I'm left with x plus 2 equals 0. So then I have 4x equals 0 So I divide both sides by 4, and I have x equals 0. Then I have x plus 2 equals 0. So x equals -2. Either way is correct. This is 100% correct, and this is 100% correct. You're good either way. Either way.
What if you accidentally didn't put the